Module 3, Exercise 4, has us preparing the model pieces in MakerWare. So what we're really going to be looking at doing is leveraging print settings as well as what we know about our current model that we're building to make the best possible print. So we'll be importing and scaling geometry in MakerWare, managing print settings for speed, quality, and need, and developing an understanding of how to look for printing errors before they happen. In exercise 4, we are working in MakerWare primarily to prepare the prints for 3D printing or to prepare the 3D model for 3D printing. But to recap really quick, we use the section box tool to divide the Revit model into east and west. And now we're going to add those files separately, one at a time, into MakerWare. So we'll select the east side first. And we're going to click Move to Platform simply to make sure that we immediately set the model on the base. At times even you won't see your model. It'll be off someplace of the XYZ Cartesian coordinate system, pretty far off of 0, 0, 0. And so Move to Platform is going to bring it front and center on your build space. So from here, we know we need to make sure that we're establishing a 16th inch scale. And we've done a bit of work for this and have come up with a simple conversion system using an Excel spreadsheet. And let's look at how this works really quick. My input value, I have 1 inch equals 8 feet in this particular case, which is not the scale we're working for. This would be for an 1/8 inch model. But we can see that this Excel spreadsheet is going to give us values to put into MakerWare. So let's change this to a 1/16 of an inch, and we're going to get a value of 158.69 that we need to establish inside of MakerWare. And basically we're getting that by taking 1 divided by my input number and then multiplying that by a 12th. That basically keeps my units together. And then we are multiplying that by a conversion factor. In this case, our Revit file coming in is in feet and MakerWare works in millimeters. So we're multiplying that by 304.8. So in our conversion factor, our scale factor, we're going to put 158.69, and that's going to give us exactly a 1/16 inch scale model. And if you want to see a little bit more about that formula, because I kind of rushed through it, that Excel spreadsheet is going to be available to you in the assets. So our printing, we're going to be using low as a print quality setting for the most part. And again, the reason why we're sticking with low rather than moving to standard or high is simply for speed. For an object like this, the quality hit that you're going to take and dropping down to low is pretty minimal. And at the same time, we're going to get faster results with a little bit less filament. So we definitely want that speed gain, unless we're working towards a final model. For me, I also don't use supports. For something like this, we've prepped the model so that we don't need them, and supports are going to add a lot of additional time and spend a lot of additional filament on the overall thing. Our minor overhangs that I'm pointing to here are all completely doable with PLA filament in a Rep 2. No problem at all on any of those. There might be just a little bit of draping, but nothing that about 5 seconds with sandpaper won't fix, or plucking out a stray strand with tweezers won't take care of. Easy stuff to work through. Next, I also typically print with a raft turned on a model like this. The reason being is that the raft builds a nice consistent base. It's going to make sure that my first layer adheres really, really well. And anytime that you've got a 3D printer in a situation where there's a lot of people pounding away on it, we have 2 Rep 2s that are shared with about 200 architecture students. And so they run nonstop. And having that raft as part of the printing process really will ensure that consistency on the first layer, which is vital in terms of getting a good first print. So it does add time. It is going to spend a little bit more material, but again, to me, it's just really worth it as an asset. So we're going to make sure that our infill is set to 10%. That's a default in terms of a low quality setting, and that's basically the amount of material that's going to happen inside of any box. So if you think of a box as having 6 sides, we're going to have layers of filament on each side with a 10% hexagon pattern infill. So we're running a preview, and I always double check my previews anytime, especially if I'm going to send something that's a fairly long print, because the preview system is going to reveal everything that's going to happen, every layer that's going to happen, and how MakerWare is interpreting the Revit model for 3D printing. So the slider on the left allows you to see every single layer as it's constructed. The top right gives me time and material. And the things that I want to really look for in this model are elements that maybe where I have a coplanar face that's joined. Every now and then I'll have a gap in the model. Not like the scene that I'm showing here, but there'll actually be something where my geometry is flipped and sort of turned inside out, and I end up with a void in my print. Revit is usually very, very good about handling this. The geometry is really tight and put together really well. I can't say that about all 3D programs, but Revit does a nice job of handling this and sends really nice, clean files into 3D printing software. So again, we can stack through all of our layers. This bottom layer is the raft that's going to print. Again, it takes about 20 minutes. If you are great, if you're a pro at 3D printing, maybe it's something you don't need to do. I kind of treat it like a security blanket, so it's something that I do like to have on my prints. Now, one of the downsides to that is right as the 3D print is finishing, you need to be there for that last 5 or 10 minutes of a print, because that will adhere to the raft permanently if it's let sit for a couple of minutes or overnight or something like that. As soon as that 3D print is finished, you need to pull it off of the base plate, and then you need to pull the raft off of the model for it to work correctly. So that pretty much wraps up the east side. Pretty happy with how everything looks. I'm okay with the time and material. And how everything is coming together on this. I'm just still taking a look through all the pieces, making sure that everything looks like it's going to print correctly. I'm going to close the preview out and export this to my final file. The next thing we'll do is simply start a new file and run through all of those steps one more time with the west end. So add a file, Museum West, move to platform, 158.69 is my scale factor for a 16th inch model. You'll notice this is hanging just a little bit off of the base, so we need to rotate this around about the z-axis. I know my model was off axis by 10 degrees. We'll just change that to -10. And now we're nicely on the base plate. Double check the settings, low and raft. We'll build the file and check the preview. And again, with this preview, this is something that I like to call a WYSIWYG. In other words, what you see is what you get. You can actually see on the preview every layer of filament that's going to happen exactly in place. So again, if there's something weird, if there's an odd gap, if there's a break in the material, if there's something that shouldn't be there, that is what it's going to try and print. So be aware of that. If you find an anomaly in the print preview, you're going to get that in your final print. So we'll export this file. Everything looked great. And now we're ready to put those files directly into the Rep2 and print them from our flashcard. Through the end of exercise 4, we were able to import Revit STL files directly into MakerWare, adjusting the scale, location, and rotation. We were able to manage our 3D printing parameters and develop virtual previews to cut off printing errors before they happen.